The dissolution similarity can be demonstrated by one of the commonly used method of F2 calculation. It is called as F2 similarity and it is related to the bioequivalence. We can show the F2 similarity between the dissolution profile of reference formulation and the test formulation. Also, the F2 similarity between the bioequivalence formulation or strength and the non-bioequivalent strength or other strength than the BE batch. When there is less than 10% difference in the dissolution profile between the two products or two formulations, then the F2 similarity is said to be achieved. The F2 similarity of more than 50 is considered to have the same dissolution profile. So whenever we calculate the F2 value to demonstrate or to show the dissolution similarity between the two dissolution profiles, consider it as one of the reference profile, second is test profile, or the dissolution profile of a reference bioequivalence batch versus the other strengths, or the product before change and the product after change. But the situation, like you may think or you may have a question that whether the F2 similarity provides the guarantee or provides the complete confidence that it will meet the bioequivalence, because the 10% difference in the profile may or may not be guarantee the bioequivalence. Sometimes we need to have the faster dissolution profile than the reference formulation. Sometimes we need to have the slower dissolution profile than the reference formulation to meet the bioequivalence. But as the requirement is there to demonstrate the similarity by F2, we calculate it and we understand whether the dissolution profile is matching or not. As per my experience and understanding, F2 similarity may not give the guarantee of bioequivalence. It may also give the indication of bioequivalence, and it depends onto the product. For some of the product, if you meet the F2 for dissolution, you may pass the bioequivalence, but in some of the formulation you may not. So F2 similarity is not a guarantee to meet the bioequivalence. Then why we need to calculate it? Because generally, as the dissolution test is a in vitro test, or you can say like it is a performance test, and if the dissolution profiles are similar, there are high chances that the product will meet in the bioequivalence requirement. So does F2 similarity guarantee the bioequivalence? So the answer is no. F2 similarity, that is F2 value above 50, indicates the comparable dissolution, but it does not provide you the guarantee of bioequivalence, and it is generally or specially not sufficient for the formulations which contain the drug substances belonging to BCS class 2 or 4, and also for the complex dosage forms. Many of the times in my experience, I observed that the 3-4 type of formulations with different design can meet the dissolution similarity or F2, but these may fail in the bioequivalence. So there are various factors, there are the problems, or there are the differences associated with the in vitro release and the in vivo release. Also, the gastric environment is very complex to understand and mimic in vitro. So IVIVC may or may not be possible every time, but the F2 similarity demonstrate or gives you the understanding or confidence that the dissolution profile are similar or not significantly different, and that's why there are high chances to pass the bioequivalence. What is F2 similarity factor? So it is a mathematical calculation which compares the two dissolution profiles, and it gives you the value of F1 and F2. So F2 we consider for the similarity in the dissolution profile, and it is used for the bioinverse. The bioinverse may be for the post-approval changes, and the bioinverse may be for the additional strengths than the B strength. Now understand about the limitations of F2. So it only compares the in vitro release, and it does not predict or it does not uh, involve the comparison of in vivo performance. In vitro and in vivo correlation may or may not be achieved by the dissolution. So there may be chances that the bioequivalence may pass or may fail. So it does not consider the effect of permeability, effect of metabolism, gut metabolism, instability in the GI variability, food effects, as the dissolution is the in vitro test. So when F2 is not enough, whenever the formulation contains the drug substance belonging to BCS class 2 or 4, which are insoluble or low soluble or poorly soluble, and may be highly or poorly permeable. For some of the modified release formulations, F2 may not be enough, and the drugs with pH dependent solubility or narrow absorption window, for these type of molecules you cannot predict the in vivo response, in vivo dissolution by the in vitro test and by the F2 calculation. Complex generics like nanosuspensions, liposomes. So complex generics solubility enhanced formulations may behave differently in the in vivo, and there may or may not be proper IVIVC by the dissolution or by the F2 calculation. In conclusion, we can say that F2 is a valuable screening tool, but it cannot replace the in vivo B studies when it is required. Use in conjunction with other in vitro test and modeling for the holistic B assessment. We don't say that the F2 value calculation is not of any use. It is a valuable screening tool, but it cannot replace the in vivo B study. It is used for the bioequivalence, and we should use it to screen the batches, to compare the batches. Regulatory authorities also recommend use for the F2 calculation, and we can submit the data as well. The applicant can get the biowaivers also, but still we need to do the bioequivalence studies. F2 value can be a very good tool to select the batches which have the resolution profile similar to the reference profile or reference formulation. So many of the professionals have the question like whether F2 calculation or meeting the F2 value guarantee the bioequivalence or not. So it is not like that. It does not give you the guarantee, but it is a valuable tool. We should use it. The regulatory authorities are also suggesting to use it, and in the formulation development, in the post-approval changes, in the application of bioviewers, F2 calculation is very, very important. I hope this video might have cleared your doubts. If you have any question, suggestions or queries, you can comment. Thank you for watching the video.